In this video, I'm going to finish the example that we started in class. So we have R1, R2, R3, R4. I'm going to fill the values in on the table. So 5 ohms for R1, 10 ohms for R2, 10 for R3, and 20 for R4. And the total voltage also was given. That was 15 volts. So the first step was to find the total equivalent resistance of all of these resistors. So these two are in series, just a pure series combination. So together, the total resistance of R2 and 3 would be adding them together because those are in series. So then the circuit can be redrawn, replacing those two in series with the equivalent resistance of 20 ohms. Well, now looking at this, I can see that these two are in parallel. We would not say these are in series because there's a branch coming out here. So these two are a pure parallel combination. And to find the resistance of a parallel combination, we need to use this equation. So 1 over, and this is going to be resistors 1, 2, and 3 combined, equals 1 over the first resistor in parallel plus 1 over the second resistor in parallel. And solving that, we're going to get that those 3 resistors combined together is equivalent to 4 ohms. So once again, we can redraw the circuit, replacing now these two with this one, and this resistor down here was 20 ohms. Now we have a series circuit, and the combination of 2 resistors in series is going to be their sum. So the resistance of 1, 2, 3, and 4, which we've been calling the total resistance of the circuit, since that's all of them, is 20 ohms plus 4 ohms, which is 24 ohms. So the equivalent resistance for the whole circuit is 24 ohms. So let's make a row here for the total values, and 24 ohms. Now we want to figure out the rest of the values for this circuit, all of the pressure differences and currents. So we know the total voltage here is 15 volts. And now I see that if I know the voltage here and I know the resistance, I can find the current. So I'm going to go ahead and do that. So total voltage difference equals the current times the resistance. 15 volts equals the current times the resistance. And calculating that, we get 0.625 amps. So that's our total flow in the circuit. And now we need to look at our circuit diagram, and we can see that the parts of the circuit that have this total flow are up here before that branch and down here until this branch. So the total flow goes through R4. So that means we know the flow through R4 is 0.625 amps. Well, if we know the flow through there and we know the resistance, we could find the pressure difference across that resistor, or the potential difference. So let's go ahead and do that. So the pressure difference across resistor 4 is the current through resistor 4 times the resistance of resistor 4. So the flow was 0.625 amps. The resistance was 20 ohms. So 0.625 times 20 is 12.5 volts. Okay, so that tells us that the pressure difference over R4 is 12.5 volts. And as I look at my circuit, the total here was 15. The amount here is 12.5. So let's see, maybe going back to this circuit would be the one to look at. So the pressure difference across the battery was 15. If If I put a voltmeter there, that's what I would measure. Across this resistor, the voltage was 12.5. So that tells me that across this one, the voltage would have to be 15 minus 12.5, which is 2.5, because this is series and so they have to add up. So whatever potential difference, voltage drop, lots of different words for that, occurs here, this one plus this one has to equal the total. So that tells me that across here, that's going to be 2.5 volts. Now if I go back up to this diagram, I can see that this 4 ohm resistor was really 2 in parallel. So from this point to this point, right, the pressure difference is going to be 2.5 volts. Well, these are in parallel, so that means 2.5 volts for this one and 2.5 volts for that one. So I can fill in for resistor 1, this is resistor 1, 2.5 volts. But this was not really one of our original resistors, was it? That was a combination of 2 resistors. So we'll come back to that in a minute. But across both of them, the voltage drop or the potential difference has to be 2.5 volts. I'm going to go ahead and finish with R1 right now because I see that I could find the flow. So for resistor 1, I can find the flow rate. .5 amps. Okay, so now let's see. We know the combined pressure difference here would have to be 2.5, but we don't know how much for each resistor. Let's see if we could do something with the current. The total flow is 0.625 amps, and at this point it's going to split, right? Some's going to go this way, some's going to go that way. The amount that went through this branch was 0.5 amps. And we can see that the flow in 0.625, it's going to divide. So if part of it goes here, the rest of it must be here. So if this much was 0.5, this over here must be 0.125, because together they have to add up to the 0.625. So this must be 0.125 amps. Now that we know the flow, oh, and the flow is the same in both of these because they're in series with each other. Now we can find the pressure difference. So multiplying the current times the resistance. So for resistor 2, 0.125 times 10 is 1.25. Oh, actually you could have just realized that they're going to be the same because the resistors are the same. So they're going to have the same pressure difference. Okay, so that wraps up this example.